Percent increases and decreases. The test absolutely loves to ask about percent increase and decrease problems. This is perhaps one of their favorite kinds of problems. So here are a couple examples of things that you might see. We're going to be talking about this in the next couple videos. Remember what we said, first of all, about multipliers in the video working with percents. There we said that the decimal form of a percent was its multiplier. Here we will change that a little bit. The decimal form of p% is the multiplier for finding p% of something. So if I wanted, for example, 30% of something, I would use the multiplier, use the decimal form. If 0.30 is the multiplier to find 30% of something, but we will use different multipliers for a 30% increase or a 30% decrease. And that's what we'll be talking about in this particular video. First of all, let's talk about percent increases. So this may be phrased as y increased by 30% or x is 30% greater than y. Either way, this is a percent increase for y. Let's think about this. If y increases by 30%, the whole original part of y is still there, plus 30% more. Therefore, the multiplier for a 30% increase is 1 plus 0.3, which gives us 1.3. The 1 represents the whole that is there, that remains there, and then the 0.3 is the 30% that is added. And so it combines to our single multiplier, 1.3. In general, if the problem talks about a p% increase, the multiplier for a p% increase is 1 plus p% as a decimal. This is very, very powerful. Thus, the multiplier for a 46% increase is 1 plus 0.46, which is 1.46. So let's talk about how to use this in problems. An item originally costs $800. The price increased by 20%. What is the new price? So all we have to do is take 800 and multiply it by the multiplier for a 20% increase. 20% as a decimal is 0.2, so the multiplier would be 1.2. So this would be 800 times 1.2. And of course we can just multiply that out and get 960. Now I might do it this way with a multiplier, or I might do it just with some number sense. I know that 10% is 80, 20% is 160, so in other words we're adding 160, 800 plus 160 is 960. That's another perfectly good way to do this. After a 30% increase, the price of something is $78. What was the original price? That's a bit trickier. So it means we had some original x, we increased it by 30%, which would be a 1.3 multiplier, and that should equal 78. So x times 1.3 equals 78. We'll divide 78 by 1.3, slide the decimal place over, 780 divided by 13, that turns out to be 60, and that's the answer. Percent decreases. This might be phrased as y decreased by 30%, or x is 30% less than y. Either way, this is a percent decrease for y. Let's think about this. If y decreases by 30%, most of the original whole of y is still there, except for a 30% that's now missing. Okay, and one way to say it really is that if 30% leaves, 70% of it is still there. Therefore, the multiplier for a 30% decrease is 1 minus 0.3, which gives us 0.7. And this reiterates what I said a moment ago. If 30% leaves, 70% is still there. In general, if the problem talks about a p% decrease, the multiplier for a p% decrease is 1 minus p% as a decimal. So for example, if I want the multiplier for a 28% decrease, that would be 1 minus 0.28, which gives us 0.72. That is the multiplier for a 20% decrease. A $170 item is discounted 30%. What is the new price? So the multiplier way to do this I form the multiplier doing 1 minus 0.3. I get 0.7. That's the multiplier for a 30% decrease. Then I multiply the price times that number, multiply out, and I get $119. Now, a totally different way to do it is, I might notice, again, this is number sense, notice that 10% is $17, the 30% is 3 times that, $51. So in other words, 170 goes down by $51. And here's how I think about this. Price goes down by $50, and then it goes down by $1. Goes down by $50 from 170 to 120, and then by $1 from 120 to 119. That makes it very easy to do in my head. Here's another problem. After an item was discounted 80%, the new price is $150. What was the original price? You might want to take a moment just to work on this, and then I'll show the solution. So here's how we'll solve it. It was discounted 80%, so the multiplier for that is 1 minus 0.8, which is 0.2. And so it means that the original x, which we don't know, is multiplied by 0.2 and winds up equaling 150. So we divide by 0.2, move the decimal, and we get 750. Now, a number sense way of approaching this, I might notice that if 80% is gone, 20% is left. That 20% is 150. Therefore, 10% is half of that, 75. Therefore, the whole is 750. That's kind of a number sense way of approaching it. Finally, finding the percent. Some problems give us the starting and ending values and ask us to find the percent of increase or decrease. Since the new equals the multiplier times the old, we could say that the multiplier equals the ratio of new price divided by old price. We have to remember that this ratio gives us a multiplier, and we have to change from that back to a percent. What was the price of an item increases from $60 to $102? What was the percent increase? So again, doing this a straight multiplier way, the multiplier equals new divided by old. So that equals 102 divided by 60. Divide both the numerator and denominator by 6. I get 17 over 10, which is 1.7. That's the multiplier for a 70% increase. For this same problem, I might notice that the difference is $42. And of course, 10% of 60 is 6, and there's 70 of those in 42. So that is another way to see that it's a 70% increase, 70% greater. The price of an item decreases from $250 to $200. What was the percent decrease? Well, again, we can use this ratio. Plug in 200 over 250, divide by 50, we get 20 over 25. We can also write this as 80 over 100. And of course, this is 0.8. That's the multiplier for a 20% decrease. I might also notice that the price drops $50, and $50 is 1/5 of 250. That's a drop of 1/5 or 20%. That's another way to see that it's a 20% decrease. If the price of an item increases from $200 to $800, what was the percent increase? Now, this is a really tricky one, and there's a trap here. Pause the video and think about this for a minute, and then we'll talk about this. So, obviously, the price was multiplied by 4. The trap answer is to believe that this is a 400% increase. That's a trap. Now, why is that a problem? 4 is the multiplier, so it's the multiplier for 4 minus 1, 3, or a 300% increase. Now, this is really subtle. We have to be careful here. 800 is 400% of 200. So that's one kind of question we can ask. 800 is what percent of 200? It is 400% of 200. But 800% is 800 is 300% greater than 200. Now that's a very different question. Not a question of what percent of, but what percent greater than. Those are two very different questions, and they have two different answers here. So in this video, we talked about percent increases and decreases. We talked about the multiplier for a p% increase, 1 plus p as a decimal. The multiplier for a p% decrease, 1 minus p as a decimal. And we talked about using multipliers to find the percent change.